multiplying mixed numbers. So when we look at multiplying mixed numbers, one of the first things that we want to just recognize is that every a mixed number, like it's much easier to do this if you convert into improper fractions, but there's other ways of doing it too. Recognize the first thing is that the part I'm actually going to focus on with multiplying mixed numbers is not actually converting it into improper fractions, because if you do, you're just going to have to convert it back again. What I'm going to focus on is I'm going to focus on the idea of distribution. Okay, because we've looked at distribution before. We've looked at the idea that if you have and I'm just going to use simple numbers for us to actually understand this real quick. If I've got 3 times 4 plus 5, right? If I've got 3 times 4 plus 5, I can do 3 times 4 and 3 times 5, giving me 12 plus 15, right? And that gives me, what's that, 27, right? The other way of looking at that is I can do the 4 plus 5 separately, right? And if I do the 4 plus 5, that's 9, and I get 3 times 9, which I can see is also 27. So that proves to us that this actually works, right? This idea of distributing something on the outside actually works, right? So all we have here is we have a multiplication problem. So this multiplication right here is what we can actually work with. And what we can recognize as well is we can recognize that this 3 and 3/7, right? So this 3 and 3/7 is actually 3 plus 3/7. Okay? That's what that is. That's that's what a mixed number is. It's one part plus another part. Okay? So what we're going to do is we're going to use that fact, and we're going to multiply that times 2, like it's in the problem, and we're going to create a distribution problem, all right? And this way we can actually break it up into 2 separate multiplications, then add it together, okay? So let's do that 2 separate multiplications. So what we have, the first one is 2 times 3. That one there is 6. And the second one is 2 times 3/7. And that's like 2 over 1 times 3 over 7. So it's 2 times 3, which is 6, and 1 times 7, which is 7. So 2 times 3 is 6, 6/7. And then we actually just have our answer just sitting right there in front of us, right, as a mixed number. So that's actually quite a simple way of looking at that. Let me plug that in real quick so you can see what I'm talking about. And it's probably the easiest way of looking at that as 6/7. And don't forget, with Khan Academy, you need to make sure you put that space in between the whole number and the fraction to show a mixed number. This would be fine as an improper fraction, but the improper fraction actually takes a little bit longer. Let me show you another example. Okay, so here's another example right there, and we've got options here. And the interesting thing about this is that it's actually it's really excluding the idea of doing doing improper fractions with this, but it's the same situation. This one here, right? That 2 3/4, that is 2 plus 3/4. Okay, so once again, all we're doing is we're taking this and breaking it up into a distribution problem. Okay, so let's do that. We've got 4/5 is our coefficient, right? That's what we're going to multiply, right? 4/5, and then on the inside now we have our 2 plus 3/4. Okay. So we've got two separate kinds of numbers in the inside, so it makes this distribution a little bit easier for us. Okay, so once again, right, we're going to distribute this. That gives us 4/5 times 2. Well, that's 8/5. All right, 4/5 times 2 is 8/5. Plus, now we have 4/5 times 3/4. All right. A little bit messier. Numerator times numerator, right? So 4 times 3 is 12. right? And denominator times denominator. 5 times 4 is 20. Okay. And of course, now at this point, what we really should do is we should convert these to common denominators just for the adding, because that's the process for adding fractions. Okay, so 8/5, we know that multiplying 5 times 4 gives us 20, right? So 5 times 4 gives us 20, right? So 8 times 4 is 32. Okay, so that's 32 20ths plus 12 20ths, which is 44 20ths, and that's equal to 2 and 4 20ths, which is 2 and 1/5, right? Now, before I just stop right there, I do kind of want to go back just a little bit and look at this from another angle, right? I want to look at this from another angle, and I want to look at it in terms of that I can actually simplify. I can simplify this into a mixed number as well, right? So here's a mixed number right here. This is actually 1 and 3/5, right? So I want to be really clear about what this is. 1 and 3/5 right there, okay? And I'm adding that. I can simplify this fraction here as well, because I have 4 goes into 20. You know, we already did this. If 4 goes into 25 times, right? And 4 goes into 12 3 times. Okay. So I want you to see that there is a different angle to this that you can actually approach it from as well, and that's okay, right? So that's all we've done is the same thing, just going it from a different perspective. And we've got 3/5 plus 3/5 is 6/5, right? So we carry over the 1 and we get 2 and 1/5 as well, right? Okay. So a couple of different ways of looking at that. That one right there. I don't see the, there it is.